So let's look at some basic probability. So if I've got a S a sample space, then and A and B are different events in the sample space, then the probability of A is always going to be between 0 and 1. And so the probability of the null set is 0, and the probability of the sample space happening is 1, right? Because if all of it is happening, it's 100% sure. If they're disjoint, that means there's no intersection, right? So if they're disjoint, then A or B is just going to be the probability of A added on to the probability of B. So if they're independent, then if I want to find A and B, I'm going to multiply them. And the probability of A complement is all of it, 1 minus the probability of A. If they're not disjoint, that's when I've got that intersection, right? And it's always good to know De Morgan's laws. Okay, so if we know that we've got A and B happening and they're mutually disjoint, so what does that mean again? There's no intersection between them. Is it possible that these could be the probabilities? No, because their probabilities, probability of A and probability of B, would have to equal 1, and they do not, right? If these are the only two events in a sample space. Okay. All right, I guess I should have said only two events, the only events in the sample space. Okay, so here I have A, B, intersection of A and B, and then C, which is everything that's not in A and B, right? So I've got this whole outside S. Here's my A, here's my B, right? And there's an intersection between A and B. And then C is all this other stuff, right? That's not in A or B. Okay, so let's find A or B. So that's going to be the probability of A plus the probability of B, subtract off A and B, because I've counted that twice. So that's 0.4 plus 0.5 minus 0.2, so that gives me 0.7. So that's the probability of A or B. So what's the probability of C then? That's going to be all of it, subtract off the probability of A or B, right? And so that's going to be 1 minus 0.7, that's 0.3. So my picture's kind of off, right? So what's the probability of A complement? That's going to be 1 minus the probability of A. So 1 minus 0.4 or 0.6. All right, so let's see what we got going on here. Joe and Alicia take a discrete math test. The probability of Joe passes is 0.7, and the probability that Alicia passes is 0.9. So they're independent. Find the probability that Joe or Alicia or both pass. So a bunch of ors. So that's going to be addition, right? So let's say Joe passes. So Joe passes. That's 0.7. And and then we'd have the case of Joe passes. Maybe Alicia doesn't. So if Alicia doesn't pass, that would be 0.1. So what if Alicia passes? That's 0.9, and Joe doesn't, so that would be 0.3. And then how about if they both pass, 0.7 and 0.9? So we're taking into account all the different situations, right? Okay, so we got two dice, they're rolled. What's the probability of getting doubles or a sum of 5? So probability of doubles or, right, sum of 5. Okay. So what's the probability of doubles? I know these are going to be independent events because I can't have a sum of 5 with doubles, right? So how many ways can I get a sum of 5? So I think 3, 2, 2, 3, 1, 4, 4, 1. So there's 4 out of 36, right? Probability is over the total number. So 2 dice, 6 sides each, 36. Probability of doubles. How many different ways can I get doubles? Well, each of the 6 numbers, there's one possibility, so 6 out of 36. All right. So what's the probability of getting doubles or a sum of 6? Okay, so this is doubles or sum of 6. Okay, so I got the probability of doubles plus probability of sum of 6. And then I have to subtract off the doubles and the sum of 6. So I know that there's one of those, right? Because that's the 2 3s, right? And so the probability of getting the sum of 6, So that's going to be, let's write out the pairs, 1, 5, 5, 1, 2, 4, 4, 2, and 3, 3. So there's 5 of those. And then probability of getting doubles, that's 6 out of 36, right? So 6 out of 36, add on 5 out of 36, subtract 1 out of 36. And that's fine to leave your answer like that. I kind of don't want simplified answers. I want to be able to see what you're thinking. All right,